Hi guys, for today's lesson we're going to be dealing with expanding a product of binomials. So some words to remember first up. What do I mean by a binomial? It's an expression with two terms. So for example 3x minus 2, we've got a term here and a term here which are unlike, and you've got this minus in between which is separating them. So with binomials you definitely need two unlike terms, otherwise they would become a single term, and we need something with two terms. Next up is a product of binomials. So when two binomials are multiplying, the word product means multiplication. So for example, here you can see this is a binomial and this is a binomial, and they are multiplying with each other. And this forms this sort of expression. We don't need to show this multiplication sign. So when you've got a product of binomials, it typically looks something like this. Each bracket will have two terms inside it, and we want to multiply these expressions together. So some rules to remember: when you are expanding, i.e. removing brackets from a product of binomials, like we've got here, we need to multiply the following terms. So whenever you're asked to pretty much get rid of this sort of brackets that we've got here, so these sorts of brackets, we need to follow this sort of process here, FOIL. So the F of FOIL means that the first terms of each bracket need to multiply. Next up, the outside terms of each bracket need to multiply. Then the inside terms of each bracket need to multiply. And lastly, the last terms of each bracket need to multiply. Once you've done all four of these multiplications, then you add these terms together. Okay, so let's give it a shot. So for example, let's expand these two binomials. We've got a binomial here and a binomial here, and they're multiplying together. These brackets are next to each other. So the idea is that we follow FOIL when we're doing this sort of thing. So FOIL, it means that the F means the first terms of each bracket. So this is our first term for this bracket. This is the first term for this bracket. We're going to multiply those together. So A times C gives us AC. Next up is the outside terms. So the outside terms of these brackets are the ones on the outside. So we've got A and D on the outside brackets, like the ones on the far left and far right. So they multiply to give AD. Then you've got the inside ones, the ones on the inside. You've got B and C, they multiply to give BC. And lastly, you've got the last terms of each bracket, which give us BD. Now all four of these multiplications need to be added together to get our expression. So once we do that, we can see that this expression here is equivalent to this expression here. One is in factorized form with brackets, and the other is in expanded form without brackets. And we always, when we got this sort of expression, we always want to check for like terms. And here we've got no letters, like letter combinations exactly the same, so we need to keep all this stuff separate. Another way to represent a binomial product is through the area of a rectangle with binomial side lengths. So another way to kind of show you that this is equivalent to this is to do it in this sort of way. So the idea is we can kind of visualize a rectangle, and one length is a binomial here, a plus b, and this length here is the length x plus y, another binomial. If we want to find the area of this rectangle, we would do breadth times length. So that's going to be x plus y times a plus b, and that looks like this, because obviously to find the area of this rectangle, you'd have to do this length multiplied by this length. So we get this sort of binomial product. Now I can also show these two multiplying like this. So I can show that this length here, a plus b, is just like this. I've got a and b up there, so the total length would be a plus b. And x plus y can also look like this, x and y there, because they would make x plus y for that total length. And if I split this rectangle up into four kind of sections, you can see that the total area of all this would be these four parts. So these four parts must be equivalent to this expression here, because they're both representing the same area. And you can see here that this little section here would be a times x to get this part. And you can see Yeah, so that's pretty much showing you the area of just that part. Then you've got this part, and this part. To find the area of the total, you'd add all these 4 parts together. So it's pretty much showing you that's how FOIL works. It just finds these 4 parts and adds them all together to find an expression for this. So therefore, that is equal to that, which is the case. So let's do some example questions with this. So expand the following expressions. Here we've got another binomial product. So the idea is we can use FOIL to help us out here. FOIL is going to be the first term. So in pink arrows, it's going to be x times 2x, which gives us 2x squared. The outside terms are going to be the x and the minus 5 to give us minus 5x. The inside terms are going to be the 6 and the 2x to give us positive 12x. And lastly, we've got the positive 6 and the minus 5 to give us a negative 30. So there's our 4 terms that we're combining. And we want to see if there's any like terms here that can simplify this expression. We've got minus 5x and plus 12x. They're like terms which make positive 7x. The x squareds and the numbers have to stay separate, so it becomes an expression with 3 terms. So this is equivalent to this. This is the expanded version of this expression. Let's do another one. We've got one here with a few more, which are a little bit tricky. You've got to be a little bit careful with your algebra. So again, we just follow the same method of FOIL. The first terms are going to be this term and this term, which make 15x cubed y. When you multiply, outside terms at 3xy times 1, which is just a positive 3xy. Inside terms, minus x squared times 5x squared gives us minus 5x to the power of 4. And lastly, minus x squared times 1 gives us minus x squared. If you look at these, there are no like terms, so that is your final answer in expanded form. Next up, a bit of a wordy sort of question. A room in a house is 4 meters by 5 meters. Both the length and the width are expanded by x meters. So both of these lengths got bigger by x meters. You could add x onto both of these measurements to get your new dimensions for your room. Write an expression for the area of the room in expanded form. So we know the lengths because they've been increased by x, but we want to find the area of the room. We have to multiply the length times breadth. So this is our old room, which is 4 by 5. And then it went up to 4 plus x and 5 plus x. That's our new room. The area is going to be these 2 binomials multiplied together because it's length times breadth. And we want to use FOIL to expand this. So you get 20 plus 4x plus 5x equals plus x squared. Simplify this by putting our like terms together to get 9x. And the 20 and the x squared come down. That is our expanded expression for the area of this new room. Okay, use this expression in expanded form to determine the area of the room if x is equal to 2. So the idea is we can use this equation here, which we've been asked to do, use the expression. And we want to increase the room by 2 meters. Our x is 2, so all we need to do is change our x to that value of 2. So putting that into the equation, that comes out as 42 meters squared. That would be at the area of this room. We can check that because this length here would have become 6 if our x is 2. So it would be 6 by 7, and 6 times 7 gives us an area of 42, which is what we found. So our expression and our answer are correct. They check out. Hope this helps with the questions. Good luck.